Dear colleagues, our report is called Design and Analysis of Spoofing Detection Algorithms for Signals of the Global Navigation Satellite System. My co-authors are the Master Engineer Łukasz Lemiszewski from Maritime University of Szczecin and Dr. Engineer Larisa Dobriakowa from West Pomeranian University of Technology, Faculty of Computer Sciences and Information Technologies. The network spoofing is an attack, in which the spoofer, hacker, attacker, offender, opponent, a bad boy, is sending a false packages in order to persuade the victim's computer that the listening computer is the final recipient. Then the packets are sent to the actual recipient. Media access control is an address of the sender is replaced in such a way that the reply packets pass through the listening computer. An attacker can unleash large amounts of noise using these devices and jam the airwaves so that the signal-to-noise drops so low that the wireless local area network ceases to function. The only solution to this is radio frequency proofing the surrounding environment. The hacker can use a high-power radio frequency signal generator to interfere with the ongoing wireless connection, making it useless. Can be avoided only by physically finding the jamming source. Attack machine associates with real access point using MAC address of the victim's machine. Attack machine is now inserted and can pass frames through in a manner that is transparent to the upper level protocols. The listening computer becomes the gateway for traffic victims and the offender gets a hearing traffic, for example, email offerings. GNSS spoofing. Civilian vehicles, such as unmanned aircraft or helicopter, the vessel, truck-type transports international routes, will be called the navigator or GNSS receiver. Navigator moves in space with the civil GNSS procedure, Model 1, and is subjected to an spoofing attack from other vehicles, which we will call spoofer. GNSS spoofing is the GNSS signal conversion technology. Spoofer plans to organize an attack so that the navigator should not know that the signal received by GNSS receiver is false. As a result of an organized attack, the navigator determines wrong time and or location. This means that the spoofer began to administer the GNSS position in time and space. The only GNSS systems which can't be deceived are GNSS military systems that utilize the principles of cryptography. However, for GNSS civil use such protection doesn't exist. Therefore the research of spoofing property for anti-spoofers design must be conducted. The spoofing main idea is illustrated in Figure 5. Spoofer is generally located in the immediate vicinity of the navigator and moves in space with civilian or military GNSS mode. Spoofer performs short-term disruption of the GNSS signal L1 using GNSS jammer, which is now very widespread. For example, a device connected to the cigarette lighter, which costs only $22, is used on a board of transports international routes for locking devices of the vehicle's registration systems. A fishing vessel is able to block the self-registration system for routing and trot fishing in foreign waters. As a result of jamming, GNSS receiver loses satellites and starts looking for GNSS signals. At this time, spoofer includes imitator GNSS signals, which is set up to imitate the new coordinates of the GNSS receiver. Generally GNSS signal strength exceeds the strength of imitator real GNSS signals and GNSS receiver can't determine from what time of its movement in space it is controlled by a spoofer. GNSS spoofing, 1D. A GNSS spoofing is performed in 3D space. To illustrate the principles of spoofing, we consider a virtual experiment in 1D space navigation. There are two transmitters S1 and S2, which move in unknown directions. Each of the transmitters S1 and S2 know their position x1' and z2' in space. Between them is a receiver R, which also moves in an unknown direction, and it does not know its position x'. On transmitters S1 and S2 are installed accurate clocks, such as atomic, and on the receiver clock is inaccurate, such as quartz. Transmitters S1 and S2 in time T1 and T2 send messages, which contain three numbers: transmitter number, 1 or 2, time of message, T1' or T2', and its coordinates in space, x1' or x2'. Receiver will receive a message at the time T1' or T2' with error of delta t. Let us represent our virtual experiment in space navigation, but in spoofing terms. Spoofer at the same time interferes with GNSS signals by jammer and transmits to the receiver amplified signals containing and information. This virtual experiment reflects the actual spoofing presented properties, thus allows a more thorough understanding of the anti-spoofing equipment, so-called anti-spoofer. GNSS spoofing detection, 1D. Since we know the location of the antenna, it is possible to determine the distance between the antennas del2x. Spoofer uses only one antenna, with which mimics the signals from the two antennas, Fig.9, substituting D1 equals D2 and D2 equals D1 into 6, we have del2x equals 0. The decision rule for spoofing detection. If del2x equals 0, then we have spoofing. Conclusion. This report describes a general approach to anti-spoofer design. Design results are markedly different, and depending on the means of communication, ships, aircraft or surface transportation, the presence of the crew on board, means of communication, drone anti-spoofing is more complicated. The limit, price and other parameters